As I said earlier, the differences between correlation and regression. Correlation is just the relationship between variables. You can exchange them also that because it's not affected by their what is dependent, what is not dependent, how is the trend changing. It's just showing you the relationship. You can interchange them, and data is represented in a single point, simple value, and simple relationship is shown. Okay, what about regression? Regression shows that one factor is leading to this much difference in the another factor. Okay, it's a more detailed test of correlation. One variable affects the other. It shows a cause and effect, that how much smoking is leading to cancer. They cannot be interchanged. Of course, you cannot say cancer is causing smoking. Now we are going into the details, which variable is affecting which variable and to how much extent that variable is affecting, and what is the relationship actually, like, is male having more or female are having more, and what is causing this differences and stuff like that. And it is represented by a line. The regression is represented by a proper line. Okay. So, what is regression? Once again, we have to define an outcome variable and a predictor variable. We have to identify which one is dependent and which one is not. In correlation, we were not doing that. We were just putting them both in the same box. A proper reasoning comes into play. It has many types: linear, logistic, and Cox. We will be just going for the first two. Cox is not related to us that much. It forecasts an effect and determines the strength of the predictors. Okay. So the first one we will be using, as we use the Pearson, we will be using that as the linear regression. Okay, it is an extension of the Pearson correlation. In Pearson, what we were doing, we were analyzing data from two quantitative variables. Okay, like weight and pain. Okay, so it assumes a linear relationship between the independent and dependent variables. We performed a correlation test between weight and pain. So and we saw there was a positive line. So it is assuming a linear relationship. And now we will see that how much weight gain leads to how much pain, okay, in the joints. And how many marks obtained depend on the number of hours studied. Dependent variable is marks, independent is number of hours. Okay. And then we have types of models of linear regression. We have a linear simple regression model and multiple regression model. Now, here we are just seeing two effects. Marks are leading to how many marks are depending on what or the study. If someone comes along and say, can no, marks obtained in exams depend on other factors also as compared to all the study. And what do they depend on? They depend on number of cups of coffee you took in on your last day. Okay. So now we have identified two factors that are affecting marks obtained in exam. So what we will do, we will go for a multiple linear regression model. Here, let me explain the things a little bit clearly. Regression is of two types. We have linear regression, logistic regression. Firstly, we are discussing the linear regression, that is between two quantitative variables, and it is further of two types. If you are just studying one factor that is leading to a cause, you will go for linear. If you are studying multiple factors, you will go for multiple linear. It is also represented by the regression coefficient R. And if you have applied Pearson correlation, then you can apply linear regression. So this is a prerequisite. You have to see there should be a linear relationship between them. Then you can go for correlation. Okay. Let me apply it. First, ensure that there is a linear relationship. And R is used for a simple correlation statistic, R square, which we will be also using that. And then there is an interpretation. Okay. And I will show you guys how to interpret the data. That will actually be in our next session. But let me show you guys how to apply it for the time being. Okay, so I will come here, and earlier we saw that there was a positive linear relationship between weight and pain. Both are quantitative. So I just found out that there is a relationship, but I don't know what relationship exists. I want to deepen further. Okay. So what I will do is I will go for the regression. Here in correlate, now we are moving on to the regression, and I will go into the linear regression. I will put weight here in my weight is uh, weight is independent and pain is dependent. Increase in weight causes increase in pain. Okay, yeah, right. Statistics, we will choose estimates, confidence interval, model fit, R squared, descriptives, and yes, this. In the plots, we will go for histogram and normal probability plot because we want to see that that data should be parametric. Continue, and I will not open this stuff up. Okay, so I will just press OK. And here we have got our data. We will be interpreting this data. Here you can see the linear relation. Here you can see the bell curve, and we will be interpreting this in the next session.